All right, here we go with chapter 5. The first section is about bisectors of triangles. So we're going to talk about a few different things. We've got perpendicular bisectors and also angle bisectors. Okay, now there's kind of three pieces to each. We've got the actual theorem, we've got the converse of the theorem, and then we've got when all three perpendicular bisectors of a triangle meet, they have their own theorem, okay, about how the pieces get split up. So, first off, a perpendicular bisector does two things. It has to be perpendicular to a segment and passing through the midpoint, all right? Perpendicular to a given segment, this would be, or side of triangle is how we will most likely be using it, and passes through its midpoint. Again, it's referring to the given segment. Some theorems deal with perpendicular bisectors, and again, here they are. These two can just converse, they're just in reverses of one another. So they, again, I'm just going to kind of point out the comma, right? What comes before the comma is the hypothesis. What comes after is the conclusion. So if you are given that you have a perpendicular bisector, then you know that it is equidistant from the endpoints of the segment. Okay, so that is what this example is showing you. Perpendicular bisector, right? If a point, now it's talking to a point, so the point we would be referring to here would be point F. So if point F is on the perpendicular bisector, and we know it is because we see the perpendicular right angle symbol and we see the bisecting, therefore F is equidistant from each of the endpoints of the segment. Well, the endpoints of the segment are G and M. F is 2.8 from G, so therefore it's 2.8 from M. That is that theorem. Okay? Now the converse, if you know a point is equidistant from endpoints, so you can see it's an isosceles triangle, that kind of thing, then you know it also is bisecting and perpendicular to a segment. Okay? Let me see if there's an example of that. So that would be like number 2, okay? This would be the converse. So it's showing you point E is equidistant from the endpoints of this segment. Therefore, point E is on the perpendicular bisector of this segment. So BF would also equal 4.2. Okay? So that's the theorem, that's the converse. So what are they giving you that's equal? The pieces of the segment or the sides, essentially, of this triangle? And that's the difference there. And again, it's referring to a point, right? So we're talking about point E, point F, point X, okay? So is this one showing the theorem or the converse? Devish, is that you? Yes, it is the theorem. You're seeing that the point is on the perpendicular bisector. Therefore, XW would equal 7.5 because point X is equidistant, right? Equal in distance from Y as it is from W. Okay? Example 2 shows a little bit of algebra here. It's saying BD is the perpendicular bisector. So we see the perpendicular. If CA is supposed to be being bisected, we know we can just set those two equal. Hence, that's why they're setting them equal. Find X. Be careful. The questions may ask you to find X, or they may ask you to actually find something else. Oh, and I just realized this was down a little bit. Sorry about that. Okay. Moving along. The circumcenter theorem. So, in a triangle, every side can be bisected by a ray, segment, or line that's perpendicular to it. So there could be 3 perpendicular bisectors. So what that is saying is where they all meet, that's called the circumcenter. Okay? the circumcenter for this picture down here, try not to make that crooked, would be this point P, okay? Circumcenter, okay? Where all the perpendicular bisectors meet. Now, why I have this picture, I want to show you that a perpendicular bisector does not necessarily have to go through an endpoint, okay? These aren't just off a little bit. Like the picture is off for a reason. If this is supposed to be a circumcenter, it's on the perpendicular bisector. It's where they all three meet. So the perpendicular one part is shown, but we need to be showing the bisecting part. Okay? And again, we don't know what kind of triangle it is. It doesn't say isosceles, so we don't know that these are the same. We just know that each side gets bisected. Okay, so the perpendicular, going back up and reading the theorem, yes, you can still see that. Perpendicular bisector of the sides of a triangle intersect at a point called the circumcenter. Okay, so that's how it's described. But what does that point also tell us? It tells us that that point P is equidistant from the vertices of the triangle. So this is where we do need to kind of edit the picture, but it's like that for a reason. However, I could draw in, so P to E is, again, that distance is to the vertex, right, of a triangle. So we're saying that P to K, again, it may be on part of the perpendicular bisector, it may not be. And P to M, those are going to all be equidistant, okay? If the sides get split in half, the circumcenter is equidistant from the angles, okay? Once again, if the sides get split in half, the circumcenter to the angles are all equal. So again, you can put 4 slashes here for all of these to show they're all equal, okay? So I didn't even look at what we're trying to solve yet. I just went with what's the given showing me. List any congruent segments. So I pretty much have marked all the congruent segments that we have. So notice how I don't have anything marked for PY, PR, PN. The circumcenter doesn't guarantee any relationships between those. Okay, so MY I have marked with 2, so I can say EY. Now, since it's the segment, I need to use congruent symbol. Okay, why don't you try the rest? Hopefully that gave you a little bit of time. If you paused it, even better, but here we go. Okay, KP, that was one of the distances from the circumcenter to the angle, or the vertice of the angle. So there's 2 things that could be congruent to. ER, RK, KR, again, there's really no, since we're not talking about like congruent triangles or anything, either order is fine here. Okay, moving along. So that was perpendicular bisector. So that was a bisecting of a side. Now we're going to look at bisecting an angle. I don't know why this gets repeated up here. I think that's a mistake. So ignore that. But now we're on to an angle bisector. So an angle bisector, if a point is on a bisector of an angle, then it is equidistant from the sides of the angle. Okay, so here we actually have a couple different ideas. It's not, no, it's actually very similar. Yeah, because this talks about equidistant from the endpoint. So, okay, but it's almost like it's opposite, right? We bisected a side, and we were equidistant from the angles, right? Equidistant from like the angles. So If we bisect an angle, we're equidistant from the sides, okay? If a point is on the bisector of an angle, that's the hypothesis, the conclusion in it, and again, that's referring to the point, is equidistant from the sides of the angle, okay? Now, when you were talking about a distance to a side, it has to be perpendicular, okay? So equidistant, I'm going to put perpendicular symbol there, okay? So using the theorem, let's check it out. Okay, this one is showing point V or point K, right, more likely, is on the angle bisector because these tiny small angles are being marked congruent, okay? So, therefore, point K is equidistant from the sides of the angle, making those two congruent. So you would set 2x plus 1 equal to 3x minus 8, and you get x equals 9. But that doesn't answer the question. Remember, we said to watch out for that. So, again, this is using the theorem. So if we actually want mk, we're going to say mk is 2 times 9 plus 1, or 19. Okay. The rest of these really show the converse. Okay, so the converse now, if a point, still see that? Yep. If a point is in the interior of an angle, if a point that is on the interior of an angle is equidistant from the sides. I think this is a typo. Whoops. If a point is equidistant from the sides, then it is on the angle bisector. So this is showing point E equidistant from the sides of this angle ABC. Therefore, it must be on a perpendicular bisector, making angle ABE also 43 degrees. Same thing here. They're marking them the same, therefore it's on the angle bisector. So angle YBA is equal to 47 degrees. And here, pretty much same picture as 1, right? They're giving you that it's equidistant. You don't know the distance like they do in 2, but it's equidistant. So that must mean this is on a bisector, making these two smaller angles. That's right. Good job, Drew. Equal. So we get 4x is equal to 16, and x is 4. But again, that doesn't answer my question. Does it matter which one I plug into? No, because EWL, which is technically this kind of left one, would be equal to this, but it doesn't really matter. I would always go with plugging into what they give you for that particular, plugging in a 4, for that particular angle. So is that 28? All right, just checking my key. 28 and 5, so that's 33 degrees. Okay. Questions? Obviously, I can't answer them right now, so let me know. Come to office hours if you have any issues. So, back up to the top here. The in-center theorem. Okay, so again, perpendicular bisectors all met at something called the circumcenter. Angle bisectors all meet at something called the in-center. So, the angle bisectors of a triangle intersect at a point called the in-center. That is, okay, so the in-center is this point, and it is equidistant from now the sides of the triangle. And again, perpendicular. Gotta be perpendicular. So, what we're showing down here on this picture, if we know U is the in-center, by using the definition, that means it's on an angle bisector. So we should be marking all these angles. So I'm going to put a 21 degrees in there. Pink's probably not showing up too well. My apologies. 21 goes there. 28 goes there. And I don't know what goes here, but I can figure it out if I needed to, okay? right? I could add up, that's 42, that's 56, and adding those up, I could figure this out and then split in half, right? For the angles of the big triangle. Okay. However, now we can mark some sides or some lengths that are congruent. So once again, this point U, is the incenter, and it is equidistant from the sides of the triangle. So the side U to P is marked as 5. So if I go U to this side of the triangle, then that means MU is 5. If I go U to this side of the triangle, UB is 5. Okay, again, the distance from the angles, there's no guaranteed comparison, so I can't really write anything for those. All I can really show, and really, again, I'm going to make a slash there because obviously 21 is not 28, so those aren't equal, shouldn't use the same marking. Okay, so give yourself a couple minutes. Answer 5, 6, 7, and 8. I will pause. You should pause. What's that, Tyler? You're not sure what to do on number 8? Well, here we go. Let's see. What kind of triangle is H, U, P? It is indeed a right triangle, where UP is 5 and HP is 12. And HU is that's exactly right, you guys. It's the hypotenuse. The H of the HL that you probably used either today or tomorrow, or I guess yesterday, depending on when you're watching this video. So we do a little Pythag it up, and maybe this is a Pythagorean triple that you are aware of. If you are, you probably already know the answer, but I'm going to write out the work anyway. So we take the square root, 13. Now, normally when you take a square root, you have to put plus or minus. So I'm going to do that here. However, my final answer is that it equals 13 because it's a side of a triangle. The negative doesn't count. But if it's just regular algebra and this isn't part of a picture, you have to have the plus or minus. Okay? Fantastic. Let me know if you guys have any questions. The assignment that goes with this will be posted and due in 2 days from whenever you got it, okay? So that means, yes, A, guys, it's due for you the day after your test. B, guys, you get 2 days. So I can't really think right now because it's late about what day that's going to be, but I will set it all up in Google Classroom and give you your specific assignments. All right. Hope you guys had a good test yesterday or will have a good test tomorrow, if that all makes sense. All right, guys. Thanks for playing. Adios.